Have you ever just looked up at the sky and wondered what it would actually be like to stand on another world? Well, today we're going to find out, and we're going to do it using one simple, totally universal action, a jump. You're going to see how a single leap can tell us so much about the incredible, diverse worlds right here in our solar system.
So that's the big question, right? How high could you really jump on other planets? The answers, let me tell you, are going to take us from these tiny little hops to ridiculously high leaps. And each one, well, each one tells a unique story about the world it's on.
But before we go anywhere, we need a baseline, a starting point. And that's right here, on Earth. Our gravity keeps our feet pretty firmly planted, so the average person can jump about 1.5 feet straight up. That's our home base. Okay, lock that number in your brain, 1.5 feet, because everything else is going to be measured against it.
So what's this invisible force holding us down? Well, that brings us to section 1, our gravitational leash. You know, it all boils down to that one fundamental force, gravity. It's the key variable in our little interplanetary jumping contest, and it's all about how big and heavy a planet is.
All right, let's put this theory to the test. Let's get this show on the road. Section 2, hopping the inner worlds. We're starting our grand tour with the rocky planets, the ones closest to the sun. First stop, Mercury. And right off the bat, check this out. Here on Earth, it's 1.5 feet. But on Mercury, where the gravity is less than half of ours, you could spring a full 4 feet into the air. That's more than double what you can do at home. You'd feel like a superhero.
But before you pack your high jump sneakers, there's a pretty serious catch. The sunny side of Mercury hits a scorching 800 degrees Fahrenheit. I mean, that's hot enough to melt lead. Then at night, it drops to minus 280. Oh, and get this. A single day there lasts 176 of our days. So maybe not the best vacation spot, you know?
All right, from one extreme to another, our next stop is the famously hostile planet Venus.
And this is fascinating. Look at that. Your jump on Venus would be about 1.7 feet, which is just a tiny bit higher than on Earth. And you might be asking, why? Well, it's because Venus is actually super similar in size and mass to our home planet, kind of like Earth's twin.
But that twin thing, that ends with gravity. The reality of Venus is a total nightmare. It has this runaway greenhouse effect. The atmospheric pressure would crush you like a tin can. And the clouds, yeah, they're made of sulfuric acid. So that extra 2 inches of airtime, it comes at a very, very steep price. Okay, let's get out of that toxic soup. Time for section 3, a leap to Mars and its strange little moons. We're heading to the planet that gets all the attention, the red planet. Now, this is so cool because it shows just how much gravity can change even in our own little corner of the solar system. On our own moon, you could leap an incredible 9 feet high. Seriously, 9 feet. On Mars, it's a bit more modest, 4 feet, which is, you'll notice, the same as Mercury. Still, way better than what we can do here. And as you're gently floating down from your 4-foot jump, you'd have some incredible stuff to look at. Mars is home to Olympus Mons, the tallest volcano in the entire solar system. It's almost 3 times taller than Mount Everest. And even though the atmosphere is thin, you could watch a beautiful blue sunset. So we've established that gravity is all about mass, right? Mars is big, but its moon, Phobos, is tiny. It's basically just a big asteroid. So here's a fun little thought experiment. What do you think happens if you try to jump on Phobos? The answer is, well, it's simple. You won't come back. The gravity on Phobos is so incredibly weak, so feeble, that one single average jump would be enough to reach escape velocity. You would literally launch yourself into space forever. So, yeah, maybe just don't jump on that one. Okay, that's a slightly terrifying thought. Let's travel a bit further out, where things are a little safer. Section 4, jumping on giants. Our journey is now taking us through the asteroid belt and out towards those colossal planets beyond. So, hanging out in the asteroid belt is this dwarf planet called Ceres. It's the biggest thing in the belt. And if you jumped here, you would soar an unbelievable 52 feet into the air. 52 feet. That's about the height of a 5-story building. You just slowly, gracefully float back down. Incredible. Next up, the gas giants. But this brings up a bit of a problem. You see, a gas giant is, well, a giant ball of gas. There's no solid surface to actually stand on, so you can't really jump. But let's imagine, hypothetically,
if you could stand on some platform way down in the clouds, where the pressure is the same as Earth's.
What would happen? Well, on Jupiter, the king of the solar system, its massive gravity would pin you down. Your jump would be a pathetic 6 inches. But then you go over to Saturn. It's still huge, of course, but it's way less massive. There, you'd manage a jump of 1.4 feet. That's almost exactly the same as on Earth.
So the planets themselves might be a no-go for jumping, but their moons? Oh, that is a whole different ballgame. Welcome to Section 5, Exploring Strange Moons. We're talking about these incredible icy worlds with some truly wild features. Let's just run through a few of the highlights. On Ganymede, Jupiter's biggest moon, you could do a 10-foot jump, and during that long hang time, you could appreciate the fact that it's the only moon in our solar system with its own magnetic field, just like Earth. Then pop over to Saturn, to its moon Titan. An 11-foot leap there would send you soaring through its thick, orange, hazy atmosphere, right over lakes of liquid methane. And finally, let's go to Neptune's moon, Triton. A massive 19-foot leap here gives you a stunning view of a world so weird, it actually orbits its planet backwards, totally against the flow of the rest of the solar system.
Okay, it's time for our final leg of the journey. Section 6, the far reaches. We are heading to the cold, dark, mysterious edge of our solar system. Way out here, we find the dwarf planets. On Pluto, you could pull off an amazing 25-foot jump. And on Eris, a very similar world, you'd hit about 18 feet. And fun fact, it was actually the discovery of Eris that made astronomers sit down and rethink the whole definition of planet, which is what led to the dwarf planet category in the first place. And all of this whole journey, brings us to this really beautiful thought from the source material. It says, the universe really doesn't care what we deem planets or moons. It's too busy with important stuff. And that's just a great reminder of our place in all this, isn't it? We're just the observers, trying our best to make sense of it all. So after this whirlwind tour, from a tiny 6-inch hop on Jupiter to a mind-blowing 52-foot leap on Ceres, we've seen how one simple action can tell us so much about the universe. It shows us that every single world has its own gravitational signature, its own story. So I guess the final question is for you. If you could take one giant leap, anywhere we've been, where would you go?